Hello, geography students, and welcome to this demo of the lab exercise, Introduction to Spatial Data Uncertainty. So this lab was developed as part of the Spatial Labs for Esri, and is an older version of it may be available via the Esri Academy. I've edited a little bit, and the steps are really very accessible for the level that you're at right now in this class. The purpose of this lab assignment is to explore the concepts that I started to talk about in the lecture component of the class, where we talked about issues of error in spatial data resulting in uncertainty. And specifically, we're looking at positional error that may come into play due to map scale. So the purpose of this lab is to give you a hands-on way of addressing that positional error. As a recap, I just want to circle back to this particular visualization. So all maps have map accuracy standards, and the map accuracy standards associated with maps that are at a scale of 1 to 24,000 say that those maps at that scale have the possibility of features being where they are, but being also off by a distance of plus or minus 40 feet. We're going to look at how positional accuracy comes into play, specifically with Fema data related to flood zones. So the primary lab question that you're going to address are what are the potential implications of spatial data uncertainty and the results of a typical geoprocessing analysis where city parcels intersect the Fema high-risk flood zones. I'm going to call your attention to the lab document, and there's some background. The learning outcomes are to, again, review geographic scale, understand how map accuracy standards translate into uncertainty in map representation, and as I said, the steps in this lab are steps that you've done before. So this lab is a good synthesis, and since we've been away from each other for a couple of weeks, this lab is a good way to refresh your skills in basic attribute queries, adding attribute fields to a table and calculating geometry, doing select by location, doing buffers, and a basic geoprocessing, and tying it all together under this concept of understanding the potential impact of positional accuracy, issues of positional accuracy on an outcome of an analysis. Okay, so the first step that we're going to do in the lab is step 1. We're going to explore the flood zone data. So we're going to go into ArcGIS, do a little bit of data exploration. We're going to do a select by attribute, SBA, on the flood zones to select the high-risk flood zones. Save this selected set as a new shapefile. Add a field, calculate total area. So pretty straightforward processing. So you're familiar with all these steps. So without further ado, let's go into ArcGIS. You should have downloaded the folder Intro to Uncertainty, and in this folder you have some additional resources, the readings that I referenced in the lecture, and the student folder, which has the 2 data sets that we're going to use. So the first data set is the flood zones, and the second data set are the parcels. So parcels are really an interesting data set. These are from 2014 in Long Beach. If you zoom in, it's all of the boundaries of the property lines. And these we're going to assume are accurate. We're not going to look at uncertainty associated with the boundaries. The Fema flood zones, however, are a data set that comes to us from the Federal Emergency Mapping Agency. And in the resources folder, there's some information about FEMA resources, standards, and if you read the documents that are in here, you will see that FEMA flood zones have a stated accuracy of plus or minus 38 feet. So that's the value that we're going to use going forward in this lab. But let's focus on step 1. We're just going to symbolize the data. So as a recap, right-click on the Fema flood zones, the Long Beach FLD has area. And we're going to go to its properties. And we're going to go to categories. And this time we're going to symbolize the data using the flood zone, FLD zone. You want to select add all values, and it has the type of flood zone, A, AE, AH, VE, X. And we're going to use unique values or way of symbolizing. So it's as you recall from the cartography lecture, these are different, they differ from each other, so you want to use not a display that goes in sequential colors, but something that's different from each other. So we'll select the default there. Again, you have to use add all values to get them to come in, and apply, and OK, and there are our flood zones in this data set. In the lab document that I've given you, I have a table of the different flood zones and what these categories are, the explanation of the attributes for these categories. So A, AE, AH, VE, and X are the different types of hazard areas. So what we want to do is select the high-risk flood zones. The high-risk flood zones are anything that are not X. Those have a low chance of annual flood. So we're going to select anything that's not X. And we're going to use the select by attributes, and we're going to select, the Word document has very detailed steps about how to do this, and you're going to use a query where flood zone is equal to A, or flood zone is equal to AE, or flood zone is equal to AH, or flood zone is equal to VE. The reason we have to repeat each, this is just structured query language, and the way that we structure the query in ArcGIS, we're using the Boolean or, so it selects any of them. If it's either that, or it's that, or it's that. So let's go back into ArcGIS, and we're going to do select by attribute, and we're going to select on the Long Beach flood hazard area where, and scroll down to flood zone and select flood zone is equal to, and this is a really good button to know and get to know. Get unique values. Get unique values will populate this box here with all of the variables or the attributes that are in the flood zone category. So we want to do get unique values, and we want to select anything that's not X. So we're going to construct our query. Flood zone is equal to A. So you just double click that, and then you select or. Flood zone is equal to AE, and then you select or. Flood zone is equal to AH, or flood zone is equal to VE. And if you want to verify your query to make sure that you don't have any syntax error, you click verify and click OK. And this structured query will select A, AE, AH, or VE, and you hit apply. And these are our high-risk flood zones in the Long Beach area. Now, as you recall, ArcGIS works on selected sets. So what we're going to do is export this as a new shapefile, and we're going to call this shapefile high-risk flood zone. So right-click on it and go to Data, Export Data. We're going to save the data set with a meaningful name and a meaningful location, and I'm going to save it as a shapefile. Make sure you change it to shapefile, and I'm going to call it high-risk flood. It will assign it the .shp. Click OK. It's going to export that shapefile. We're going to add it as a map layer. We can unselect our selected features because remember ArcGIS only works on selected sets, so you don't want to have anything confusing it. And there you have your high-risk flood zones in the area of Long Beach. Okay, next we want to calculate area into the high-risk flood zones. And we're going to calculate area as square meters. So we right-click on high-risk flood zones, open its attribute table, pull down this little arrow on this table icon, and add a field. The field is going to be M2 for meters squared. We'll have it make sure that it's a float because we want decimal places, and we click OK. Once we have the field in the table, right-click on the field, and this time you're going to calculate geometry. Click yes and make sure that the units are square meters. So you have to change the units, click OK, and yes, and it populates each polygon with the square meters of the high-risk flood zones. Now, if you go back into the lab, the first question is, what is the total area of high-risk flood zones in square kilometers? Well, I guess you could calculate them in square kilometers, but what I wanted you to do was convert the meters squared to square kilometers. What you need to do is get the right-click on the meters squared and go to statistics, and it tells you what the total area is in sum in square meters. And I will leave it to you to convert the square meters to square kilometers and answer that question in the lab document. So I'm going to pause here and send you off to the next video where we will take on step 2 in this lab assignment.